The abyss awaits. What happens if you fall into a black hole? Part 1. Stepping into the cosmic abyss. Welcome, mystery seekers, to Extraterrestrial Mystery. Today we're diving into the ultimate cosmic enigma, a place where reality bends, time warps, and the laws of physics unravel. Picture this. You're floating in space, staring into a void so dark it swallows light itself. Around its edge, a strange glow flickers, and if you look closely, you see yourself, not once, but 100 times, like a cosmic hall of mirrors. This isn't science fiction. This is a black hole, the universe's most mysterious and terrifying phenomenon. And today, we're going to answer the question that haunts every stargazer. What happens if you fall into one? For the next 2 hours, we're embarking on a journey to the edge of reality, guided by the hard science of Einstein's general relativity and the mind-bending wonders of black holes. We'll explore the supermassive black hole at the heart of our galaxy, Sagittarius A*, and imagine what you would experience if you plunged into its depths. From warped time to infinite densities, from glowing disks to your own mirrored reflections, this is a trip that will leave you questioning the very fabric of the universe. So, buckle up, dim the lights, and let's fall into the abyss together. Let's start with the basics. A black hole isn't just a thing in space. It's a tear in the fabric of reality itself. Even Albert Einstein, the genius behind relativity, didn't believe they could exist. He called them God dividing by zero. A place where physics breaks down, where gravity becomes infinite, and where time and space lose all meaning. He thought they were a mathematical quirk, too bizarre to be real. But guess what? Humanity proved him wrong. We've found black holes, and they're as real as the stars above. Black holes form when massive stars, dozens of times larger than our sun, reach the end of their lives. They burn through their fuel, collapse under their own weight, and shrink into a point of infinite density called a singularity. This isn't just a tiny star. It's a cosmic monster that warps space-time into a deep, inescapable well. Nothing, not even light, can escape its pull. That's why we call it a black hole. Not because it's a hole in space, but because it's a void where physics as we know it ceases to exist. This journey isn't about small fry black holes. We're aiming for the big one. Sagittarius A*, the supermassive black hole at the center of our Milky Way galaxy. With the mass of billions of suns, it's a beast that's been photographed by humanity, one of only 2 black holes we've ever imaged. Imagine a shadow the size of our solar system surrounded by a glowing ring of superheated matter. That's our destination. So what happens if we send you hurtling toward it? Let's set the stage and find out. Part 2. The birth of a cosmic monster. We're back, seekers, ready to unravel the mystery of black holes. Before we throw you into the jaws of Sagittarius A*, let's understand how these cosmic titans are born and why they're so strange. It all starts with a star, a massive one, far bigger than our sun. When it runs out of fuel, it doesn't just fade away. It goes out with a bang, collapsing into a point so dense it defies comprehension. This is the singularity, the heart of a black hole, where all its mass is squeezed into an infinitely small space. But a black hole isn't just a point. It's a region of space-time warped beyond recognition. Einstein's general relativity, the theory that revolutionized physics, tells us gravity isn't a force pulling objects together. It's the curvature of space-time caused by mass. Think of space-time as a rubber sheet. A bowling ball, like the sun, makes a dent, and planets roll around it, following the curve. A black hole? It's like dropping a cannonball so heavy it rips through the sheet, creating a bottomless well. That's what makes black holes so powerful. Nothing, not even light, can climb out of that well. Back in 1939, Einstein himself doubted black holes could form. In a famous paper, he argued that stars collapsing into singularities was nonsense. Nature wouldn't allow it. But in the same year, J.R. Robert Oppenheimer, the physicist behind the atomic bomb, and his colleague, George Volkoff, misnamed Hartland Snyder in the original script, begged to differ. They showed that a massive star could collapse under its own gravity, shrinking into a point where density and gravity become infinite. Their prediction was a game changer, proving black holes weren't just math, they were real. So, how does something become a black hole? It's all about the Schwarzschild radius, named after German physicist Schwarzschild, who solved Einstein's equations during World War I. This radius is the tipping point. If you compress any object's mass into a sphere smaller than its Schwarzschild radius, it becomes a black hole. For the Sun, that's about 3 kilometers. Imagine squeezing our entire star into a ball the size of a small town. For Earth, it's 9 millimeters, the size of a marble. And for a human, you'd need to be crushed smaller than a proton. That's the kind of extreme physics we're dealing with. Now, let's choose our black hole. We could pick a small one, formed from a single star, but where's the fun in that? We're going for Sagittarius A*, a supermassive beast with a mass billions times our Sun's, sitting at the Milky Way's core. It's so big, its event horizon, the point of no return, spans the size of our solar system. That's the monster we're sending you toward. Ready? Let's set up the experiment.
Part 3. The journey begins. Welcome back, Seekers. It's time to launch you into the cosmic unknown. We're parked in a spaceship 100 million meters from Sagittarius A star, the supermassive black hole at the heart of our galaxy. You're about to take the plunge, free-falling toward its event horizon, while I stay safely aboard, watching. To track this wild ride, we've given you a special watch. It shows 2 times, yours as you fall and mine as I observe from the ship. Why? Because near a black hole, time itself starts to play tricks. General relativity tells us that time behaves differently in strong gravitational fields. The closer you get to a black hole, the more space-time warps, slowing time for you compared to me. It's like the movie Interstellar, where hours near a black hole equaled years back on Earth. Our watch will reveal just how weird this gets. So, we sync it up, you take a deep breath, and you begin your descent into the abyss. As you start falling, the view is breathtaking. Ahead, you see Sagittarius A star's accretion disk, a swirling ring of gas and dust being devoured by the black hole. Friction heats this material to millions of degrees, glowing bright blue or white in reality, though simulations often show it as orange for clarity. It's a cosmic spectacle, like a fiery whirlpool in space. Simulating this disk on a laptop would take over a decade. That's how complex this dance of matter and gravity is. After just 30 minutes by your watch, you've covered 0.1% of the distance to the event horizon. I check my watch on the ship, and I'm only 11 seconds ahead. Not too crazy yet, right? But the black hole's gravity is already bending light around you, creating strange visual effects. This is gravitational lensing, where light from the back and sides of the black hole curves toward your eyes, making the universe look warped, like a funhouse mirror. The black hole's shadow, the dark region where light can't escape, looms larger, growing faster than you'd expect. That's the lensing effect at work, bending light paths to distort your view. You're still far from the event horizon, but the universe is starting to feel alien. What happens as you get closer? Let's find out. Part 4. Time warps and cosmic mirrors. We're back, Seekers, and you're plunging deeper towards Sagittarius A star. The black hole's gravity is tightening its grip, and things are getting seriously weird. Your watch says you've been falling for 2 hours, covering 1.4% of the journey to the event horizon. But when I check my watch on the spaceship, I'm only 44 seconds ahead. Time is starting to slip out of sync, a preview of the mind-bending effects to come. The view around you is unreal. The accretion disk blazes brighter, its light warped by the black hole's gravity. Stars and galaxies behind the black hole appear distorted, stretched into arcs and rings by gravitational lensing. It's as if the universe is being painted on a curved canvas, with the black hole as the artist. The black hole's shadow grows larger, dominating your field of vision, like a dark void swallowing the cosmos. Now, let's talk about the photon sphere, one of the strangest places in the universe. You're not there yet, but you're getting close. This is a region where the black hole's gravity is so perfectly balanced that light itself can orbit it, like planets orbiting a star. Photons, particles of light, get trapped in circular paths, creating a glowing ring around the black hole. If you paused here and looked around, you'd see something jaw-dropping. Multiple versions of yourself. Here's why. Light from your body, emitted in all directions, gets bent by the black hole's gravity. Some of it loops around, coming back to your eyes from behind. You'd see the back of your own head not once, but many times, like standing in a hall of mirrors. It's not magic, it's space-time doing what space-time does near a black hole. The photon sphere is a cosmic funhouse where reality twists into surreal shapes. But you're not pausing, you're falling. Time dilation is kicking in harder now. After 12 hours by your watch, I've been watching you for nearly 15.5 hours. The gap is widening, and the black hole shadow is growing, filling your vision with darkness. You're still far from the event horizon, but the universe is starting to feel like a dream or a nightmare. What happens next? Let's keep going.
Part 5. The Point of No Return. Welcome back, Seekers. You're hurtling towards Sagittarius A1, and the black hole's pull is relentless. You're now dangerously close to the event horizon, the invisible boundary where escape becomes impossible. Your watch says you've been falling for 13 hours, with just 24 minutes to go before you cross that line. But on my spaceship, I've been watching for nearly 20 hours. Time is stretching like a rubber band, and the universe is about to get even stranger. The black hole's shadow now dominates your view, a vast darkness that seems to swallow everything. The accretion disk glows fiercely, its light bent into a halo around the shadow. Gravitational lensing is in overdrive, twisting light from distant stars into bizarre patterns. You can even see parts of the universe that should be behind the black hole, their light curved around it like a cosmic mirage. It's beautiful, terrifying, and utterly alien. You check your watch again, 18 minutes from the event horizon. For you, it's been a matter of minutes since the last check. For me, it's been 18 hours. The time dilation is staggering. Your final moments are stretching into hours for me, and it's only going to get worse. The black hole's gravity is warping space-time so intensely that every second for you feels like an eternity for me. As you approach the event horizon, you don't feel anything special. No alarms, no flashing lights. The event horizon isn't a physical barrier. It's just a point where the escape velocity exceeds the speed of light. You can still look out and see the universe, distant stars, my spaceship floating safely away. But all that light, like you, is doomed to fall toward the singularity at the black hole's core. What's it like to cross the event horizon? And what happens when you reach the singularity? Let's dive deeper into the abyss. Part 6. Crossing the Cosmic Threshold. We're at the edge of reality, Seekers. You're just 6 minutes from crossing the event horizon of Sagittarius A1. Your heart's pounding, your watch is ticking, and the black hole looms like a cosmic predator. You take a deep breath, check your watch one last time, and it seems broken. It says, "I've been watching you for an infinity amount of time." But it's not broken. This is the magic of physics, where time itself bends to the will of gravity. From my perspective on the spaceship, your journey is slowing to a crawl. As you near the event horizon, time dilation becomes extreme. Your final 6 minutes stretch into decades for me. I see you moving slower and slower, your image reddening as the light you emit shifts to longer wavelengths, a phenomenon called redshift. Eventually, I'd need an infrared telescope to even see you. To me, you never quite cross the event horizon, frozen in time at the edge of the abyss.
But for you, the experience is different. You cross the event horizon without noticing. There's no sign, no barrier, just a point where the universe's rules change. You can still look out and see the stars, my spaceship, the glowing accretion disk. But all that light is falling inward, just like you, toward the singularity. You're past the point of no return, and there's no way back. Inside the event horizon, things get weirder. You're heading toward the singularity, a point of infinite density where space-time collapses. But a common myth is that you'd see the entire future of the universe unfold thanks to time dilation. Not true. As you approach the singularity, aberration, the distortion of light due to your motion, compresses the outside universe into a tiny, bright ring in your field of vision. You won't see galaxies evolve or stars die. You'll see the cosmos squeezed into a shrinking circle, fading as you fall. What's next? The singularity awaits, and it's not going to be pretty. Let's brace for the final plunge.
Part 7. The Singularity's Embrace. Welcome back, Seekers. You've crossed the event horizon of Sagittarius A*, and now you're inside a black hole, a place where the laws of physics break down. You're hurtling toward the singularity, the point of infinite density at the black hole's core. What happens here? Let's explore the terrifying, mind-bending reality of your final moments. As you fall, the black hole's gravity grows stronger, pulling harder on your feet than your head. This is spaghettification, a gruesome effect where tidal forces stretch you like a noodle. Your body elongates, compressed side to side, and stretched head to toe until you're torn apart at the atomic level. For a supermassive black hole like Sagittarius A*, this process might be delayed until you're closer to the singularity, but it's inevitable. You're becoming one with the black hole, your matter merging with its infinite density. What's the singularity like? We don't really know. It's a point where density is infinite. Time stops, and our physics, Einstein's equations, quantum mechanics, falls apart. To escape, you'd need to move faster than light, which is impossible. You're trapped, your fate sealed in a realm where space and time lose all meaning. From my perspective on the spaceship, I never see you cross the event horizon. You're frozen at the edge, your light redshifted into oblivion. But for you, the journey is swift. You fall, you stretch, you merge with the singularity, all in moments. The universe outside shrinks to a pinpoint, and then nothing. You're part of the black hole, lost to eternity. This raises a profound question. What does it mean to enter a place where reality itself collapses? Let's reflect on the science and mystery of black holes. Part 8. The Science of the Abyss. We're deep in the cosmic unknown, Seekers, and the journey into Sagittarius A* has shown us the raw power of black holes. But let's step back and unpack the science behind this wild ride. How do black holes work, and why do they challenge everything we know? General relativity, Einstein's masterpiece, is the key. It tells us that mass warps space-time, and black holes are the ultimate example. Their gravity is so intense it creates a deep well, trapping light and matter. The event horizon marks the boundary where escape velocity equals the speed of light. Cross it, and you're gone. The photon sphere, just outside, is where light orbits, creating those eerie images of your own back. And at the core, the singularity defies physics, a point of infinite density where our equations break down. The Schwarzschild radius is what makes black holes possible. Any object compressed to this size becomes a black hole. It's why a star can collapse into one, why Earth could theoretically become a marble-sized black hole, and even a human could, if squeezed to an unimaginably small size. This universality is both beautiful and terrifying. Black holes are a cosmic rule, not an exception. Our journey also highlighted time dilation, a hallmark of relativity.
Near a black hole, time slows for the observer, stretching minutes into decades. This isn't sci-fi, it's math, straight from Einstein's equations. The movie Interstellar got it right, showing how time near a black hole can feel like an eternity elsewhere. It's a reminder that our perception of time is fragile, shaped by gravity's whims. But black holes aren't just theory. We've seen them, thanks to the Event Horizon Telescope, which captured images of Sagittarius A* and another black hole in 2019 and 2022. These glowing rings of light surrounding a dark shadow are proof that black holes are real, not just Einstein's God dividing by zero. What does this mean for us? Let's explore the bigger picture.
Part 9. Black Holes and Human Curiosity. We're nearing the end, Seekers, and the journey into Sagittarius A* has been a wild ride. But why are we so fascinated by black holes? What do they tell us about our place in the universe? And why do we keep chasing their mysteries? Black holes are more than cosmic oddities. They're a challenge to our understanding. They push the limits of physics, forcing us to confront questions we can't fully answer. What happens inside the singularity? Is information lost forever, or does it escape somehow, as Stephen Hawking suggested with his famous radiation? These questions drive scientists to build better telescopes, run complex simulations, and dream up new theories. The story of black holes is also a story of human triumph. Einstein doubted their existence, but Oppenheimer and others dared to believe. Decades later, we photographed Sagittarius A*, turning theory into reality. It's a testament to our curiosity, our refusal to accept impossible. Every black hole discovery, every image, every equation is a step toward unraveling the universe's secrets. For us, black holes are a mirror. They reflect our fear of the unknown, the abyss that swallows light and time. But they also reflect our wonder, our drive to explore. Falling into a black hole, as we imagined, is a journey of awe and terror, a reminder that the universe is vast, strange, and beautiful. It's why we tell stories like this, why we look to the stars and ask, what's out there? But black holes aren't the only mysteries. The universe is full of wonders, from water worlds like K2-18b to the déjà vu that makes us question reality. How do black holes fit into this cosmic puzzle? Let's wrap up with a final thought. Part 10. The Eternal Mystery. We've reached the end, mystery seekers, and the abyss of Sagittarius A* has left us in awe. For the past 2 hours, we've fallen through a black hole, felt time stretch, seen our own reflections in the photon sphere, and merged with the singularity. But this journey is more than a thought experiment. It's a window into the universe's deepest secrets. Black holes are where physics breaks, where time and space become meaningless. They're proof that reality is stranger than we can imagine, yet within our grasp to study. From Einstein's skepticism to the glowing ring of Sagittarius A*, we've come a long way, but the mystery remains. What lies beyond the event horizon? Is the singularity a door to another universe, a glitch in reality, or just the end? This journey connects to the bigger picture, like K2-18b's oceans or the déjà vu that haunts our minds. Black holes challenge us to question reality. They remind us that the universe is a vast, unknown frontier, and we're just beginning to explore it. Every discovery, from a chemical hint of life to a photograph of a black hole, is a step toward understanding our place in the cosmos. So here's my challenge to you, seekers. Share your thoughts in the comments. Have you ever wondered what's inside a black hole? Do you think we'll ever solve its mysteries, or is the singularity a secret we'll never crack? And what other cosmic wonders do you want us to explore? Drop your ideas below. We're building a community of cosmic dreamers. If you loved this plunge into the abyss, hit that like button and subscribe to Extraterrestrial Mystery. Next week, we're chasing another cosmic enigma, so stay tuned. Until then, keep looking up, keep wondering, and watch out for those black holes. The universe is waiting, and its mysteries are calling.